In this video, I want to talk about two different kinds of variables, categorical and quantitative, and ways to graph categorical variables. We're going to start with a data set that I have on Google Spreadsheets. I set this up. It has 4 different data sets. You can find it in a link below. You can make a copy of the data yourself and play with it. I'm going to start with the US Senate. The US Senate has 100 senators, and this is the 2020 version of the US Senate. The first variable here is the state from which the senator is from. Richard Shelby and Doug Jones are both from Alabama. The state is an example of a categorical variable. I can't do any kind of math on that, but it describes the senator. It categorizes them. The party affiliation is another example of a categorical variable, as is the gender and the birth season. On the other hand, age is an example of a quantitative variable. Richard Shelby is 85 years old. Doug Jones is 65 years old. Richard Shelby is 20 years older than Doug Jones. Makes sense to compare them. Richard Shelby assumed office in 1987. Doug Jones assumed office in 2018. Richard Shelby assumed office 31 years before Doug Jones. Again, it makes sense to compare those two quantities. I'm going to click on Russell Westbrook's season from 2016 and 2017, and I can see that rebounds, assists, fouls, points, and minutes played are all examples of quantitative variables. I can compare them, I can do math on them. I can average the number of rebounds that Russell Westbrook has had for the first 5 games. I can do math on it, it's quantitative. Now, a difference between fouls and minutes played as variables is that fouls is an example of a discrete quantitative variable. I can count them, 0, 1, 2, 3, 4, 5, 6. If I can count them, then it makes sense to describe them as a discrete variable. On the other hand, I can't really count the minutes played. I can measure them. So I can measure them with a clock, and the more accurate my clock, the better measurement I'm going to get from minutes played. So in the first game, Russell Westbrook played 36.38 minutes. In the second game, he played 45.32 minutes. If I can continuously get closer and closer and better measurement, it's a continuous variable. If I look at the Kansas City Chiefs, a player's weight is an example of a continuous variable. The better my instrument is, the more precise measurement I can get for the weight. Whereas the number of years in the league is an example of a discrete. So this is the number of full years in the league. So Jody Fortson here is a rookie. He has had no complete years in the league until the season's over, at which point he has 1 year in the league. Let's go back to the US Senate, and we're going to divide all 100 senators by gender and their birth season. So I went ahead and already set up this table. It is a two-way table. You've got the one category, gender, up top, and the other variable, their birth season, on the left. And I have filled in all the frequencies. So all 100 senators are divided into one of those 8 groups. Now, I'm going to go to this website called Stapplet.com. It's a website we're going to frequently use and for all sorts of graphing, analysis, etc. I'm going to hit on one categorical variable, multiple groups. I'm interested in graphing a categorical variable. There are 4 categories here, so I'm going to make it 4 categories. But I went ahead and filled in the data in another tab, and I'm going to go there. So I'm going to edit inputs. There's all my data, and I'm going to hit begin analysis. The default graph that I have is a segmented bar graph. So this is a graph that has appeared frequently on the AP exam, and it lets you compare proportions within the 2 variables. I can tell that a higher proportion of males were born in the winter than females that were born in the winter. On the other hand, a higher proportion of females were born in the spring than males born in the spring. 36% of females were born in the spring, and only 35.3% of the males were born in the spring. But it doesn't tell me if there are more females born in the spring than males born in the spring, because it doesn't tell me the proportion of males compared to the proportion of females of the total population. And that's where a mosaic graph comes in. So I'm going to switch from chart type from segmented bar graph to a mosaic plot. And now I can tell there's a pretty big difference. I can tell that there's significantly more males than females based on the shear area. Now when I'm comparing the females in the spring to males in the spring, I can see that 9% of the whole population of the Senate, or females born in the spring, and 19% of the population of the whole Senate are males born in the spring. So even though a higher proportion of females were born in the spring than males born in the spring, if I look at the sheer raw numbers, more males are born in the spring than females. A mosaic plot is a better representation of the raw data than a segmented bar graph, and you want to be able to know the difference between the two.